Hey, now there is something I've been thinking about since I was a kid. It has to do with Albert Einstein's theory of relativity and the special relativity. He had a thought experiment that involved a light clock that supposedly someone would be holding. There was a beam of light that would come out the top, reflect off the bottom, and come back to the top. And every time that light beam went up and down, it would be a second. He states that if it's in motion, then there would be what's called time dilation. And I'll explain a little bit more of this, but there would be an angle of that light beam in that clock that would cause that time to be slightly off because it would take longer for that light beam to go on an angle and back up. And I'll show you here in a second what they say about that.
Initializing Techman systems. Neural sync complete. Welcome to Techman channel.
Okay, I wrote a little Python program to demonstrate Einstein's light clock thought experiment. It should be noted that a light clock does not physically exist. It's merely a thought. Also, Einstein would have assumed that nothing in this light clock can defy the law of physics. Now, this is the model that I've seen proposed by physicists. Assume that this box is 150 million meters by 150 million meters. There's a photon emitter at the very top. Every time a photon travels down 150 million meters and back up 150 million meters, it'll equal 1 second, being as the speed of light is roughly 300 million meters per second. And that would be indicated in this top right corner right here. I could scale this down smaller. It would just mean that this photon would bounce 110 million times if the clock was 15 meters by 15 meters, and you really wouldn't see the experiment, nor would it really change the outcome. In the thought experiment, there's a man out here in space holding this clock. There's also a man on Earth watching this man. The experiment states that the observer and the man holding the clock would be counting the same time and seeing the same photon bounce if the man was standing still. Now, if the man was in motion, traveling linearly this way, and this is currently set to 100% light speed, so the man is currently running at 100%. The man holding the clock would see this photon still travel up and down inside this clock by his own perspective, and the observer would be seeing this diagonal path right here. It's said that since this diagonal path is longer than a straight path, it must mean the observer is counting the man's seconds slower than the man is counting his seconds. So that means the observer is observing the man running at a slower time. This is where my controversy comes in. And as you can see in this demonstration, the photon isn't actually traveling diagonally. It's still traveling up and down. The observer may see a diagonal streak in this model. It isn't actually traveling diagonally at all. I'll now change this down here to 50, meaning that this man is now traveling half the speed of light. The angle here is changed, but the photon still travels up and down at the same rate as before. And as you can see, it still equals 1 second to the observer and to the man holding the clock. In this model, it's my belief that both the man holding the clock and the observer would be seeing and experiencing the same time with no time dilation. One big problem in this model is it defies Newtonian law. Newton's law states an object in motion wants to stay in motion. Well, this photon appears to be traveling with the clock as it's whizzing through space, but a photon isn't an object. It has no mass, so the photon would behave much like the next model. This model right here shows the same photon at the same speed as the previous model. It travels up and down in the same speed. Now, I had a problem getting the logic correct within the program, but this model still kind of proves my point. Since this photon has no mass and it can't travel forward in its trajectory along with the emitter, the photon is now stuck out into this space. Technically, to the observer, the man, and to the man holding the clock, they would both be seeing this happen. If they both saw the photon act like this, they would still be counting the same time at the same time. Now, you can kind of think of this, and I don't have visuals for this, you can just imagine. A spaceship is flying by Earth, let's say at half the speed of light. It was told to shoot a target on Earth with a photon from a laser. He would have to shoot the laser while directly above it as he's traveling by. The ship and the observer on Earth would see this photon coming from the same spot as emitted from, in a straight line down to the target. In no way would the man or the observer see this photon taking any angular path.
Well, let's do another experiment. It's the same clock. It still can't defy any laws of physics. So let's say we turned it sideways. It's the same clock. Let's measure time this way. Okay? So now the light beam is emitted. It moves a half because he's traveling this way still at the half speed of light. He's gotten here, that light beam would be right here. He's gotten here, that light beam would be here, and here, and the light beam would be here. So it is moving, but it's moving half the speed as it would have been up and down. So it's moving half as fast this way. So by the time he gets to this point, that light beam would have hit the bottom of the mirror at the bottom here. Well, we're going to start the experiment back at square one here and say that that light beam has traveled this far, and now it's got to head back because it's bounced off the bottom. So now we're moving another half, and that light beam would be here. We moved another half, that light beam is here. Another half, and that light beam is here. So now we're running faster this way than we did this way. It's basically running twice as fast this way as it ran this way. So the observer watching that would be seeing it go very slow and then very fast back up to count its 1 second, which is the same time that the man holding the box is seeing. He's seeing 1 second go by at the same time that the observer is seeing 1 second go by. So after my experiments, my conclusion is that relative motion does not affect time. It only affects the clock. Now, I tried to hit every point that I could to the best of my knowledge. I'm not a physicist, I'm not a scientist, but I've read Einstein's book when I was a kid. I was 18, 19 years old, and I bought it. And it's up in the attic of my other garage right now. But after I read that, I started thinking about this light clock and time dilation, time travel. And I've been thinking about this for almost 30 years now. Every day I think of something new or something different, a different aspect of it. But I try to touch on it as best as I could think of. And again, I'm not a physicist. I can't say that Einstein's theory of relativity is law. So nothing that I said in this video is against the laws of physics. It's only against the theory of physics. And it might give you something more to think about. I'm not looking to break new ground. This is what I've been thinking about. And I want to give others a chance to think about a thought experiment. So that was the purpose. And I've been wanting to create a video or tell somebody my ideas or what I thought about a thought experiment. So I hope you could take away something from it. It's hard for me to speak sometimes with my aphasia, but I'm just trying to get out as best as I could my thoughts on this thought experiment. I will be having another one coming up about Stephen Hawking's book, Theory of Everything, as well, and he dives into some of the black holes and some of those theories. I'm going to post something on that as well when I get a chance. So if you like it, then like it, subscribe. If you want to see more, it's going to be more random things whenever I get around to putting it on there, but I hope somebody gets something out of this. Thanks.
You've been watching Techman Channel. Transmission terminated.